In this video, we want to cover how firewall rules are structured and why the default deny principle is critical in OT environments. Being able to read a rule set is a practical skill, and it lets you audit a firewall configuration, spot gaps, and understand exactly what traffic is and isn't permitted between zones. The default deny principle determines which failure mode you live with, and in OT environments, that is important. A firewall rule has 6 components, and every rule in every firewall uses some version of these same elements. First, we have the action, or what happens when the rule matches. Our choices are permit, allow the traffic through, or deny, block it. The protocol specifies the transport protocol, TCP, UDP, ICMP, or sometimes any for rules that apply regardless of protocol. The source is where the traffic originates. A specific IP address, a range of addresses specified as a subnet, or any for all sources. The destination is where the traffic is going, has the same options as the source. The port or service specifies the destination port number for the service being accessed. For example, port 502 for Modbus, or port 22 for SSH. Finally, the order is the position of the rule within the rule set. Rules, again, are evaluated from top to bottom, and the first matching rule determines the action. A packet that matches Rule 3 never reaches Rule 4. Rule order is not just housekeeping, it determines which rule actually applies when packets match multiple rules. Let's go through an example. Here's a simple firewall rule set protecting PLCs in VLAN 10 from the SCADA servers in VLAN 20. In Rule 1, we have permit TCP from source 10.20.1.10, our SCADA server A, going to destination 10.10.1.101, which is my PLC 1 on port 502. My second rule is permit TCP from source 10.20.1.10, that same SCADA server A, going to a different PLC, 10.10.1.102, PLC 2 on the same port number 502. Rule 3, we have a permit TCP, source 10.20.1.11, which is SCADA server B. Allow it to go to destination 10.10.1.101, which is my first PLC on port 502. Finally, Rule 4 is deny any, source any, destination any, port any. Rules 1 through 3 permit the specific SCADA polling paths that operations requires. Rule 4, the last rule, denies everything else. This last rule is the default deny, and it's the most important rule in the set. Any traffic that doesn't match rules 1, 2, or 3 is blocked. An engineering laptop in VLAN 30 trying to reach PLC 1 on port 502, blocked. An unknown device trying to reach PLC on any port, blocked. Traffic from anywhere to port 23 on a PLC, blocked. Default allow means all traffic is permitted unless a rule explicitly blocks it. You write deny rules for the things you don't want, and anything without a deny rule goes through. Default deny means all traffic is blocked unless a rule explicitly permits it. You write permit rules for the things that aren't allowed, and anything without a permit rule is blocked. In an OT environment, default deny is the best approach, and here's why. With a default allow, a missing deny rule is a silent vulnerability. If you forget to write a deny rule blocking telnet, then telnet traffic flows freely. Nobody gets an alert. The gap may not be discovered until an assessment or an attacker finds it. The failure mode is invisible. With a default deny, a missing permit rule breaks a service immediately. If you forget to write a permit rule for the historian's backup polling path to a specific PLC, that polling fails. The historian team gets an alert about missing data. The failure is visible, loud, and gets fixed within hours. You now would fix it with the correct permit rule. Default deny fails loudly. Default allow fails silently. In OT security, visible failures that get fixed are much more preferable to silent vulnerabilities that go unnoticed. So you should check every OT firewall you're responsible for. If the last rule in the rule set is not an explicit deny all, that firewall is running default allow by omission. Everything that doesn't match a permit rule is permitted by default. and that's a critical finding. A rule set is only as good as its ongoing maintenance. Rules accumulate over time, added for specific purposes, but never removed when the purpose ends. Every rule in a firewall should have a documented business reason. Again, if you can explain why a rule exists and name the systems and people it serves, that rule is a candidate for removal. And allow any rule that someone added during troubleshooting just to test and never removed is a rule that bypasses all other controls. Establish a regular review cadence for firewall rule sets, annually at a minimum, after any significant network change. For each rule, verify does the source device still exist? And does the destination device still exist? Is the protocol and port still what the application uses? Is the business reason still current? Remove what's no longer justified, document what remains. In the next video, we'll cover some of the most common firewall misconfigurations, the patterns that render even correctly placed firewalls ineffective. These are the findings that show up most frequently in OT security assessments.